Hey, this is KD0FNR,
And I'm KO6BTY.
and we're going to walk you quickly through our QSO log that we store in a SQLite database and then display like this using a open source Python package called dataset, and that is used for data analysis, and Simon Willison wrote that. This is an SQL query that we're running against our log, and it's going to show us some QSOs that KO6BTY made on June the 6th.
So what it'll do is we can see where we transmitted from, where the person we were talking to was transmitting from, and we can put in the code for the ionosonde.
And what that'll do is that's going to pull out the height of the ionosphere at the time of the QSO. These are the ionosondes that are available around the world, and KO6BTY programmed it up so if we just give it the code for the ionosonde, and we can pull the codes from right here, and that's what you see over in our query. As the query runs, it's going to pull in the height of the F2 layer on the 6th of June at the time of the actual QSO. So let's go ahead. We're going to hit run, and what you're going to see over here in the terminal window is you'll see it bringing in the data. And so we'll see that the height was 260, and you can actually see it change. So here, right at the end, the height went up to 305 point, and actually that's actually the start of all the QSOs because they're sort of backwards. But we started out at 305.2 kilometers up, 267. There's 260. So the ionosonde updates its information about every 7 minutes. And then what we wind up with
Is a really cool map.
Yep, and we wrote that using the JavaScript Cesium plugin. And so you can see I'm going to go ahead and start it, and it's going to start in the middle, but let me back up. So at the start, we have all the QSOs for that particular span, which is about an hour. And so you can see the one that went to all the way to Argentina, and you'll notice there's there's also lines that go up,
And those are hitting the height, going up to the height of the ionosphere at the closest time, and heading back down to whoever we were talking to.
and then that way we can also not only see where we were talking from and to, but visualize that F2 skip, which is kind of fun. And then we're going to zoom back out. And I guess the only other thing to show you, the big reason that we're using Cesium is we can actually see, based on the time of day, where things are. So we're going to zoom back out a little bit.
It's like a giant spider.
Right. And come on. There we go. And so we can actually see that we were not too far beyond gray line when the QSOs were made. Although we lost control of it. There we go.
Cool.
And so you can see over here, still daylight. And over here,
About gray line.
Yep, it was just about gray line. And as we move the slider, you can see, and I guess that's the other thing, is that we can also see the QSOs as they were being made. And right now we're running 1 second per minute. And it only took about an hour, so you're not going to really see gray line move on this one.
But if we took like a whole day.
But yeah, some other data sets where we do the whole day, you can definitely see gray line truck along. There's one down to Argentina.
Mm-hmm. All right.
And that got everything done. And so yeah, just kind of a cool thing we did. Cesium made it really nice because Cesium can do sunlight versus time of day, and so we can find out things about the gray line by using Cesium. and it's a nice little set of tools. Thanks.